So let's just get down and to the point. Comes to you in a box. It's not a bad little case. It does have a plastic hinge on it, which I don't exactly like, but either which way, we'll get this open and get on with it. Comes with your regular instructions and whatnot. Don't need those. One charger, 2 battery packs, which is what we're after. 1 plastic wrapped 3/8 driver. Now it does come with some other sockets, 3/8 to 1/4 adapter, all 3/8 sockets, various sizes. We're not here for that. Let's get that out of the way. So, 1 ratchet, 2 batteries. So, first off, just by looking at the configurations of the pack, it does state it's 12 volt, but it will be a 3-cell 18650 12 volt instead of a 4. It's indicated by what would be, you know, an 18650 here and there. So when I originally got this, I literally wanted it just so that way I could tear the packs apart, or at least one of them, and do a comparison between a factory pack and one that I do with cells of my choosing. So out of all the 3/8 ratchets that I looked at online, different reviews, I know another channel, Project Farm, done one with 4 different reviews between Milwaukee and even all the way down to Earthquake from Harbor Freight. I picked the middle ground here, and that was really about the only reviews that I could find that was a real negative for this. Was one of them talked about how the battery packs, they just were not up to par. So I said in the event that I wanted a 3/8 driver, and since I've done other videos on rebuilding packs, I said I can fix that. So I'm gonna literally take one, disassemble it, we'll figure out what the cells are that are in it, and then we will take another one and run it as a factory. I'll fully charge this one. Once I get the other one done, I'll fully charge it. And then we will somehow set up a comparison between the two to see if there's a difference in output and runtime, which theoretically there should be. Now these are your regular negative post. This is after 2 cells connected together. It's not indicated on here, but this would be at theoretically, you know, 4.2 times 2 would be 8.4, and then this is your full 12 volts. Now this one is labeled as T, which is typically reserved for your temperature. But what I find odd about these packs is that there's actually, on the side of it, there is a spot for a barrel connector. Now, before shooting this, I did go from the negative to the positive post in there, and I did get the full 12 volts. So I'm not real sure if this is actually for the temperature probe that's inside of here, or should be in here, or if it's a secondary way to actually charge these packs. So, without further ado, we'll go ahead and get on with this. Get one of these torn apart, and we'll see what the cells are, and then try and make a decision as to what cells we want from there. So initially looking at the packs, they're different from the, I think I done a Milwaukee one of these one time, and it was a snap together case. But when I started looking at the build design, I can see here on the side the tip of a screw, and then you might not be able to see it, but down in here there's another one, and so that led me to believe there are screws underneath this sticker. So first we'll get this sticker off the side of here, or off the end of here. Shouldn't take too much. It's probably just a plastic style. Well, there's one hole already. Now mind you, I've never even charged these packs. I've never fully cycled them, anything like that. This is day one. It came in the mail today. The entire kit with a coupon from Amazon was $85.58 shipped to the door. Let's see, so these are 3 regular Phillips heads. They're not a security bit apparently, which is a good thing because I don't have my security bits here today. Now hopefully these are going to be somewhat decent cells. If not, I'll end up having to order more cells and just do both battery packs eventually. The end of it already wants to come off, which is a good thing. Hopefully they're not all glued and strapped together. So yeah, one end cap, a little rubber, and they're not clipped in, so yeah, it just slides out. Alright, so yeah, I was correct that it is a barrel connector. I'm not sure if it's to actually charge it or not. I may attempt that, but I'm not going to currently do it since I'm not after that, and I don't have anything ready to put out a fire if I do. So contactors look, or not contactors, but the contacts look nice and heavy, good and sturdy built. And they are a SunPower lithium-ion INR 18650-2000. Let's see, INCMR 18/65, 11/20/20. So potentially the build date. Don't quote me on that one. So we will need to go and pull up the specs on these and see if they actually live up to their names or not. And then see if we can't figure out what the continuous current draw is, if they're protected or not. And I'm not real sure. Let's see. Okay, well, pull this rubber off. Regular rubber. Foam gasketing. It's like a 4-spot spot weld on each of them. Doesn't look like much penetration, but you know, you don't always have to have a whole lot of penetration like regular welding. I'm gonna have to take a soldering iron and undo that one so that way I can pull the circuit board up. So it does look like the circuit board is made separate from the cells themselves. So yes, there is a temperature in here, but it doesn't look like it's even, may not be noticeable in the camera, but it's actually not even really on the cells very well. I know that's probably thermal conducting silicone or glue, but I mean, it's almost like it's sitting out here with the tape itself and not actually on the cells. So fault for them on that one. No! And this one may actually look like they soldered it on. I'll have to look into that a little bit further. Got that wire unsoldered, and then eventually you can kind of work this up. Now, what I did realize was that there is a tab on this one that is soldered into the circuit board. So once you actually unsolder it, the board will come up. You can fold it over, pull that extra little piece of cardboard off, and then you can actually see that that one was welded to it. So I'm not gonna break it down any further, but again, we do have the SunPowers. So doing a little web digging, this is what we came up with. Now this was pulled from the SunPower website itself. I'm not exactly too confident in some of those, considering that, you know, if you're trying to sell your own products, sometimes they inflate things. So when you go down through here, I'm having a little bit of a tough time understanding what they're actually trying to pull off here. Is that, let's see, where's it at? Max continuous discharge current of 20 amps. Well, this is fine, which I find it hard to believe that that's going to come out of that. I could be wrong. But the bigger one is the rated capacity of 2,000 milliamp hours, or 2 amp hours, which is what it actually says on the bottom of the sticker. Let's see where to go. Here we go. 12 volts at 2 amp hours, or 24 watt hours. In parentheses, you have this 0.2C and this cute little 5 down here and an amp symbol. So the rated capacity of 2,000 milliamp hours, with a parentheses like this, it's showing that you're going to get the capacity at 0.2C. Now, C ratings, off the top of my head, if I remember right, is essentially what you have for capacity is 1C. So if you have 2 amp hour, 1C charge rate would be 2 amps. So in this case, if that's, you know, the way they're doing it, you'd have 0.2 of 2,000 milliamps. And so that's a very small discharge rate to get to this 2,000 milliamps. Minimum capacity, again, of 1950 at 0.2C. So the rest of it looks kind of normal. Weights, charging, temperature. So I went back and I dug a little further to see if, you know, typically when you find contracts and things that have these little numbers, you would normally have like a number 1 first, and 2, 3, 4, and so on until you get to 5. Well, I couldn't find any of those, but when you scroll further, you get a little further down, you get into the electrical characteristics. Now, this is where it gets a little more confusing. Is that under the discharge rate capabilities of 1C, which should be 1C is 2 amps, or 2 amp hours, then these are all the standards and so on. Now, they keep doing this, instead of this 5 dropping down here out of the way like they do here, it stays up here. So it gets a little trickier. So you can do 1C, 5C, and 10C, which again, 10C would be 20 amps. So capacity retention, here's where it gets a little fuzzier. At 1C charge rate and 10 amp discharge plus 500 cycles, cells should be charged in accordance with 0.5C. Again, not sure if that's 5 amps or if that's even supposed to be in there, but that's a 0.5C, or 1 amp for 2,000 milliamps. You get the point. Charge condition, rest at the end of the charge. The voltage is 4.15, and then rest for 10 minutes. Discharge at 10 amp discharge to 2.75 volts. 1 cycle is finished, rest for 30, then repeat the steps above. When the capacity is less than 70% of the initial capacity, the battery life is over. Well, if that's the case, then I'm not sure if they're saying this is 10 amp discharge and you get 500 cycles, or if that was the actual standard of how they'd done it. So when you order the Kimo, they talk about their battery life and over 1,000 charge cycles. Well, so far their standard testing is only showing a discharge plus 500 cycles, and it deteriorates even worse for when you do a 20 amp discharge for 200 cycles. So again, you discharge at 20 amps and the rest, the battery rests for 30 minutes and then repeat. So I don't really trust all this, you know, with this funky lettering and so on, but what I do have is I have a load tester at the house that will test it. I can at least do a 10 amp discharge rate. I'm obviously not going to do 500 cycles, but I will test at 10 amps, which would be the 5C rating. And I will see if I can even pull anywhere near what they talk about. Because according to this, I may have to actually go down to a 0.2C to be able to get to the 2,000 milliamps. So I will get some more footage of that once I get these to the house and get them clamped up and run a discharge cycle or 2. Probably do the best out of 3 just to make sure. So going with these standards, 20 amp discharge continuous and a discharge voltage cutoff at 2.75. That would bring me to the replacement cells that are potential candidates. Would be an LG Kim HG2 and a 3,000 milliamp hour. Now LG is a little bit better of a name than SunPower. So standard charge rates are good. Constant current for a fast charge is even better. So end voltage cutoff. The other one's a 2.75. These are 2.5. So that'll be even better. You know, you'd still have a 0.2 volt buffer at the bottom end of it. Continuous discharge, as the other one has, that's a 20,000 milliamps or 20 amps. And that would be able to give us our 20 amps of draw capability continuous, still fit the low voltage cutoff, and potentially, if the sun powers aren't lying, and you actually do get the 2,000 milliamps, then going to 3,000 milliamps, you should actually be able to improve by at least a third. So I will look at this, and then I will get some sun powers to the house and get one of these pulled apart, or just leave them together and put some clamps on it. I will do some testing, get some numbers off of the cells themselves, and see what we can't get.
Round 2. Fight!
As we've seen earlier, we got the paperwork out. Showed a max continuous discharge of 20 amps. I wanted to know, so off to at the house, grab my load tester. These are fairly cheap. You get a hold of these, you can plug virtually anything into it via barrel connector or regular leads. I'm not going to go through all of it, but I did fully charge these and start to play around with one cell, and I'm going to tell you now, it's not going to work out. This one right now is at a 4.21 volts, which is slightly overcharged. That's not what we want. But for the sake of actually doing the testing, when they talk about a 30 amp pulse, I can't pull 30 amps with this tester, but I can pull at least 10 amps or 150 watts, either which way you want to look at it. The bottom voltage cutoff is 2.75 volts. I can't get the 0.75, but I do have it set for 2.8. So that way we have a low voltage cutoff. If it drops below 2.8, then it'll stop the test and start beeping and yelling at me. Upwards of 10 amps or 150 watts. So volts, amp draw. So as I turn these up, this will show the current amp draw, the amp hours if you're running for time down here, and the watt hours. So we'll see if we can even the max continuous discharge current of 20 amps or a 30 amp pulse for 2 seconds. Let's see where we can even get to before it yells at us. There's one. We're already dropping down 3.5 volts at 1.5 amps. Get upwards of 2 amps. 2.5. Well, cut. So we can pull 3.2 amps. Well, I can't even do that. 3 amps continuous. So that is not good whatsoever. There is no way that you're going to be able to pull any sort of power from it. Go ahead and write that in there at 3 amps. So they're claiming 20 amps. I don't know for how long. If you're getting a 30 amp pulse for 2 seconds, I doubt it, because I can't even, look at that. I can't even get that much out of it. All right, reclipped. New cell in, 4.21, 4.2. Everything's zeroed out. It does have the 2.8 cutoff, so there'll be a small difference between it and 2.75. 0.2C, which is 0.4 amps. And, well, let me clear this down here to make sure. That's 1:59 time. All right, now get on with it.
Boring.
Backlight, volts, volt cutoff, amps, watts. All right, let's see if I can get to 0.4. That's a coarse knob. This one's the fine knob. 0.4 amps or 400 milliamps. After an excruciating 5 hours of watching this thing tick away, we have managed to pull the 2 amp hour rating at a 0.4 amp rate, and it is struggling for voltage. It is dropping fast. Yet another round of testing. Cell is fully charged, 4.2 volts. Everything's zeroed out. Earlier, we tried to do a 20 amp constant discharge. We could only maintain 3 amps. So let's just go ahead with a 2 amps or 2000 milliamps and see what it pulls in an hour. This is not looking good already. 1.99, close enough. The voltage cutoff is still at 2.8, so I'll speed through this and get to the results. Ha. And at a whole 29 minutes, we are hitting the 2.8 cutoff at a full 2 amps. So, I guess if you were to break it down to maybe an amp, you'd probably pull a full 2 amp hours in an hour. But that's only at a 1 amp hour or 1 amp draw rate. Now there's the full test, all 3 cells. It did finally come out. As I talked about before, I think one of the other tests we done a 0.5 amp, and we ended up not getting the full 2000 milliamps out of it. So out of the cheap SunPower cell, 1000 milliamps or 1 amp hour, it was a normal test, so it drains it all the way down to a, I'll have to look it up again, but it drains it down, cuts it off, gives us our readout for our milliamps, which was 2125, and 4.19 is how it's recharged. It took 4 hours and 11 minutes to get it done. Now, the other 2 cells, they came in a bit better. Obviously, I wanted a 3500 milliamp, and it's recharging it now. It took almost 7 hours. Same thing, almost identical for the other cell. Obviously, I'll run the third one through there and write the milliamps on the cells themselves, that way I know what they are. Next up, we've got to get these out of here and rebuilt into the actual pack itself. So over here we have the 1 amp test with the SunPowers. Looks like this one come in at 2151, 2163, 2169. So fairly consistent across the board, even all of them at a 1 amp draw rate. Well, as we see here, these are some LGHG2s. Went ahead and run them through the tester as well, just to make sure that they are all pretty much the same. Well, we got some good news, we got some bad news. Bad news was I couldn't get my LGHG2s in the mail in time. It was taking a little bit of a while, so as you may have noticed in some of the testing, we had the 18650G8s from Sanyo. Went ahead and threw them in there. It's a 10 amp discharge rate with a 3500 capacity rating, as seen by the indicators, or the testing. But that'll give us a base model, one that is factory, still has a sticker, one with replaced cells, no sticker. So now I'm gonna have to, I don't know, somehow devise a test between the 2 of them. Probably have to make up some random studs with some nylon block nuts and see how well it does and holds up. One of the things that I did come into with some of the testing, this turns out it's a dumb charger, and by that I mean that it has just 2 terminals in here and it just spits out voltage in amps. So on the back of it, and we'll get in a little bit more here. Ooh, a little too far. All right, so at 13.5 volts at 1500 milliamps, or an amp and a half. When I was doing some of the readings with a voltmeter, I was trying to figure out what we were doing on the batteries and the boards. And it turns out that, some of the, I want to say it's the Milwaukee, but it has more tabs and keeps track of temperature, etc. And in this case, that may be what's causing some of the issues with the batteries in the Kimos. Is this is just a dumb charger. It just puts out volts and amps if it needs it. Now, when I had this pack apart, and I was doing some testing with it. I was making sure that all 3 cells were good to go before I stuck it in the charger, and what I found was that I didn't have one of them fully charged. So I stuck it in the charger anyway, just to see if it was an actual balance board, and turns out it's not. So what I was doing was, I thought, okay, well, maybe the board, you know, didn't like the cell being so low in voltage, so I started to bring it up closer and get it a little more in line with the other 2. And what I found out is that it didn't want to balance them at all. I mean, when you would stick it in here, it would just go from a red light to a green light and say that it's good. Well, when you pull it apart and you individually test the cells in between, there was more than, I want to say, 0.1 volt difference, which I mean, it's not that big, but it is in my case. So I like to have a little bit tighter tolerance on cells, but I ended up max charging them all. I will keep an eye on that, since I can tear these apart a little more. Hold on, let me get that out. It's a half modded iPod 5th gen. It's going to a solid state and some other stuff. Be on the lookout for that one. I get that out of the way. So what I'll be able to do is pull these apart and start watching the cells a little bit more and see if it does pick up and start to balance. But from my initial testing, that is not a balance board that is in there. It is just simply a board. So next up is we'll start doing some factory testing versus the 18650 GAs. And then what that will set up for is depending on how it turns out, most likely I will replace my other factory packs with the LG HG2s, and then we will be able to do a test between the HG2s and the Sanyo GAs. Therefore, having 2 rebuilt packs with a heck of a lot better performing cells than these junk SunPowers that are in here. As we've seen from some of the testing, it just, I'm not a real big fan of them. Can't really find much resources on them other than what I've been testing them with. So right now it does check out. I have kind of, you know, stuck them in there just to make sure that they work and that I do have a functioning driver. It is variable speed, which is kind of nice. And a little battery gauge to let you know when they're full and running down. And then, of course, verifying. I will have to figure out RPMs and see if it even makes a difference, but from initial playing with it, just to even see, I believe there's more circuitry in here. Obviously, I don't think it's going to be the battery that limits the RPMs because of this being a variable. So, not sure if even having different cells is going to be that big of a difference in output. It could just very well be the circuitry in here being the limiting factor, and the only difference would be is that these are just difference in capacities. So I may end up ultimately with essentially the same performance, but one in a 3000 milliamp and one in a 3500 instead of the regular factory 2000s. So next up, we will apparently get some bolts and some nuts and see what we can't do for drivers and see what else we got.